So this lesson is going to be lesson 8. This is going to involve quadratic functions and their properties. This is going to come from 4.3. Remember, quadratic also stands for these square functions. So remember, quadratic also referring to the square function. So we're talking about those U-shaped graphs or those parabolas. So those are some things that we should pick up on from that word parabola. So remember, a quadratic means we're talking about secondary functions. So that quadratic term, we have to have the power of 2 present. It's got to be the highest degree in the function. It's got to be the biggest exponent. If it's not there, then we would not have a quadratic. So again, we're going to focus on those transformations. We're going to be talking about vertical stretches and vertical shifts. So we're going to be focusing on that. Something else we're going to get into is determining the vertex and the axis of symmetry. We're going to get into those two things that we've not really talked specifically about so far when we talk about the characteristics of a quadratic function. We basically just said it's a parabola, and we've been just plotting these 3 order pairs to graph it. One of our goals also is if we give you we want to write an equation if given the graph of a quadratic. So if we see a quadratic graph, in other words, if we see a parabola, we're going to try to write an equation that fits that graph. And of course, applications. So we're going to look at some applications involving the quadratic function. As I said, a quadratic function is a second degree function. So remember, the simplest is just having this x squared. So that would be a quadratic function. Notice how if we have x squared plus 5, we recognize this as on the outside of a shift vertically of 5. But the ones we're not as familiar with is this guy right here. So in working with this guy, we're going to learn more about how to graph him. So notice how he does have the x squared term, but how do we go about graphing will be tricky. So again, the form of a quadratic function is we're going to have this ax squared plus this bx plus c. Remember how before we had what was called a quadratic equation. A quadratic equation, we had ax squared plus bx plus c was equal to 0. That was a quadratic equation. Now, instead of having this 0 is turning into a y. So now it's becoming an input-output. So now writing this as y equals ax squared plus bx plus c. So that we're no longer calling the y value 0. It's now going to be depending on what the x value is. So we have this, we're going to create these input-output tables. And of course, instead of using the y, we can now use this fancy notation, this f of x, for our function. So in talking about transformations, as I said, the coefficient of a, that's going to affect the graph as a stretch or a compression. So remember, the graph of a quadratic function is called a parabola or U-shaped. And this coefficient is going to affect the graph in 2 ways. So one of the things we're going to talk about is if a is greater than 0, in other words, if a is positive. So if a is positive, what's going to happen is the graph is going to be opening up, or sometimes we use this word concave up. So instead of saying curves up, concave up kind of represents a curve. If a is less than 0, in other words, if a is a negative number, then what's going to happen is the graph is actually going to be opening down or concave down. So the U shape is going to be opening in a downward direction. So notice how we have this equation y equals 2x squared. Notice how the coefficient is a 2. Since that's a positive 2, we should recognize that this graph is going to open up. So the coefficient of the quadratic term is going to determine whether it opens up or down. If I go ahead and graph this, remember the parent function is that -1, 1, 0, 1, and 1, 1. So if I was graphing the parent function over here, I'll just do this in green. We'd have that -1, 1, 0, 0, and 1, 1. And the graph would kind of take on that curve there. It'd be that kind of shape there. But if I graph this y equals 2x squared, notice how the 2 is going to affect the y values. So the y's are all going to be multiplied by 2 now. So instead of having a -1, 1, I'm going to have 2 times 1, which would be 2. And instead of having 0, that should be 0, 0. I'm sorry. Where did I get 0, 1 at? I graphed 0, 0. So 0, 0 there. So if I graph the -1 is now going to be -1, 2, and 0, 0, when I multiply 0 by the 2, that's still going to be 0. And again, the x value doesn't change, but 2 times 1 would be 2. So my new graph, notice again, is going to be -1, 2, 0, 0, and 1, 2. Notice how the graph still opens up. It's just what we call vertically stretched. The y values are further away from the x-axis. So it would be the sketch of my graph. So the 2 is going to kind of tell me that this graph opens up. Notice how I have this -1/2 x squared. Notice how, again, the coefficient is a negative number. So right off the bat, I should recognize that this graph is going to be opening down. So as far as the points go, you know, if I do the parent function to start with. So my parent function again is y equals x squared. So if I graph the parent function, we have -1, 1, 0, 0, and 1, 1. So if I graph them over here, -1, 1, 0, 0, and 1, 1. So this graph would kind of take on this look here. So now when I graph y equals -1/2 x squared, the -1/2 is, again, it's on the outside, means I'm going to be multiplying the y values by -1/2. So -1/2 times y would be what's going to be happening to them. So notice how this is going to be a compression and a reflection. So this graph should be opening down instead of up. So again, the x values aren't changing, -1, 0, and 1, but this y value is turning into a -1/2. 0 stays put, and that turns into a -1/2 as well. So we have those points there that I could kind of sketch. Let's see here, make that a little bit more legible. So again, -1, -1/2. This graph is going to now be going down 0, 0, and then 1 would be -1/2. So notice how this graph is a little bit wider because the points have gotten closer to the x-axis, which kind of compresses it and makes it wider. But the key thing is picking up on that this negative number actually makes the graph open down is one of our pickups on there. So next thing we're going to get into is this vertex. A vertex is a special point on which, if the parabola opens up, it's going to be the lowest point on the graph, which we would call a minimum. And this graph will turn at this point. And as I said, this will be a minimum point. So I really didn't need that twice. So the slowest point, the graph will turn at this point. Oh, come back here. Where'd you go? So again, we talk about the vertex. It's going to be the special point on the parabola. Again, if the parabola opens up, it's going to be the lowest point on the graph. And the graph will turn at this point, and this will represent what's called a minimum point. If the parabola opens down, it's going to be the highest point on the graph, and the graph will turn at this point, and it's going to represent what's called the maximum point. And recall earlier when we talked about local maxima and local minima, we're going to be using some of those same concepts here. So to determine the vertex of a function that's in this form here, ax squared plus bx plus c, we actually use this formula that is x equals the opposite b over 2a. This is going to find us the x value of the vertex. So you'll see this quite a bit, this x equals negative b over 2a. It's a formula. And we're not going to get into how it's developed at this time. So to find the y value, what we do is we substitute the x value into the function and work it out to find the y value of the vertex. So if I have the function 2x squared plus 8x plus 5, and if I want to find the vertex, what we're going to do is we're going to use x equals negative b over 2a to find the x coordinate, to find the x value. So again, notice how a is equal to 2, b is equal to 8, and c is equal to 5. For us to find the x value of the vertex, x equals the opposite of b, and since b is 8, that's going to be a negative 8 over 2 times a, and since a is 2, that's going to be 2 times 2. So I'm going to have this negative 8 over 4, and negative 8 divided by 4 would be a negative 2. So once I find the x value, I can now find the y value. So instead of using f of x equals 2x squared plus 8x plus 5, remember that's y equals 2x squared plus 8x plus 5. And so now what I'm going to do is replace the x value with the negative 2 and work it out. So 2 times negative 2 squared plus 8 times negative 2 plus 5. And I'm just going to let the calculator do that. So we'll put that in there. So 2 in parentheses, this negative 2, close parentheses squared, plus then 8 times negative 2, close parentheses there, add 5. Looks good. And that's going to give me a negative 3. So my vertex is going to be the ordered pair, negative 2, negative 3. And that's going to be the lowest point on the, since this graph opens up, this will be the lowest point on the graph. So when x equals negative 2, the minimum there would be the negative 3. So we'll get into more information as we go on about graphing it. We just want to find the vertex there. So the axis of symmetry is the next thing we want to kind of talk about. The axis of symmetry is represented by a dashed vertical line when I graph it. And what it does, it passes through the vertex. And this graph is going to be mirrored on each side of this symmetry, this line. So to find the equation for the axis of symmetry, we use the equation x equals negative b over 2a. So the equation of the axis of symmetry, again, is going to be x equals some value a. And what we're going to be looking for is this here. So that kind of gets confusing there because this a is not the same thing as the other a. So let's maybe call it something else here. So the equation is going to be x equals the this value that we get when we do this negative b over 2a. So the axis of symmetry is an equation of a vertical line. And remember, a vertical line, we use the letter x in the equation. So to find the axis of symmetry, again, we're going to be using this formula x equals negative b over 2a. And again, our a is equal to 2, our b is equal to 8, and our c is equal to 5. So when I use this formula, it's going to be the opposite of b, so it's going to be a negative 8 over 2 times 2. which is going to be -8/4, which equals then this -2. So the equation for the axis of symmetry is x equals -2. Notice we've already kind of did this up here when I found when I used x equals -b/2a up here. Notice I got this x value is equal to -2. So really it's the same math, but now we have to write the equation of a line. So now they want this equation x equals -2. So we actually have already done the -b/2a. We didn't have to do it again, but the equation is going to be this equation of this vertical line, which x equals -2 is going to represent that. So that's how we find the axis of symmetry. Again, is we use a special formula x equals -b/2a. Now, the vertex form of a quadratic equation, some quadratic equations will be written in the form of a times x minus h squared plus k. This is called the vertex form of the equation. So notice how this h and k will be the order pair for the vertex. So I don't actually have to use this formula x equals -b/2a. This h here and this k here will be the vertex for the quadratic function, the parabola. So if I give you this equation, f of x equals x minus 3 squared plus 5, notice that I can identify the vertex as simply this is your h and this is your k. So that's going to be then 3, 5 is going to be your vertex. So get my face out of the way. If I look at this next equation, I have f of x equals 1/4 x plus 1 squared minus 2. Notice how again your vertex is going to be this and this, but notice how this is a +1. Remember, inside is always backwards, so that really means a -1, and the outside stays the same, a -2. So notice how this actually was a -3, but that really means to move right 3. So that vertex is going to be located at that 3, 5. And then if you have a +1, it's actually going to be a -1 for the x value. The y value is just what you see on the outside. So remember, we kind of get that from those transformations. So if I have this +4, notice how my vertex is actually going to be this -4, 7. That's going to be my new vertex. And here, if I have x plus 4 squared, notice how there's not a value for k out here. It's actually a 0 out here. So notice how this only slides to the left 4, but there's no movement on the y value. So the vertex is just going to be now at -4, 0. So remember, when the shifts, inside is always backwards and outside is normal. And that's how we find the vertex of a quadratic function if it's in that form. So let's graph the two above functions using transformations. So the ones with asterisks, we want to graph those. So let's graph first off x minus 3 squared plus 5. So let's start with that one. F of x equals this x minus 3 squared plus 5. Let me double check, make sure I got that right. Yep, that looks good. So remember, in graphing these functions, we want to also find a few things. What we want to do here is we want to graph by locating the vertex. We also want to identify the line of symmetry. So the vertex is going to be 3, 5. Now remember, the axis of symmetry. So this is the vertex here, 3, 5. And the axis of symmetry, remember, it's an equation, x equals. And remember, x equals is simply the x value of the vertex. So x equals 3, because remember, the axis of symmetry has to pass through the vertex, and it has the same x value as the vertex. From there, we should be able to just sketch a graph of the parabola. And notice how the A is positive since there's no negative out in front. that means this graph should be opening up. So if I go right 3 and up 5, that would be the vertex. The vertical line is this x equals 3. This graph does open up. I do need one more point. So I'm going to pick a value just to the right of the 3. I'm going to pick x to be 4. If x is 4, I'm going to put that into the problem. 4 minus 3 squared plus 5. So 4 minus 3 is going to be 1. 1 squared plus 5, well, that's just going to be 1 plus 5, which is going to be 6. So 4, 6. So I'm going to have also this point 4, 6. And the axis of symmetry means there's another point mirrored over here. So that would now give me enough information to sketch the parabola at that spot. So by knowing the vertex, the axis of symmetry, and one more point, I can now sketch the graph, especially if we know that since A is positive, it's going to open up since there's no negative out in front of that. So this next one we want to graph is going to be -3 times x minus 4 squared. So I have f of x equals -3 times x plus 4 squared. And what else do we have up there? Plus 7. Okay. So let's come back down here and add a 7 to it. So the first thing we pick up on is we're going to identify the vertex. The vertex is going to be identified by, we have to use the opposite of 4 and this 7. So the vertex is going to be -4, 7. So when I graph this, I'm going to graph -4, 1, 2, 3, 4, 7 would be, looks like about here. -4, 7. The axis of symmetry, so the axis of symmetry is going to be an equation of a line. And remember, it's just the x value of the vertex. So x equals -4 is the axis of symmetry. So it's a vertical line that passes through this. Now, since A is negative, we know this parabola is going to open down. So I'm going to find another point. And so I'm going to pick a value to the right of -4. I'm going to just choose -3 just to the right of it. So I'm going to put -3 in for x and just see what happens to the math. So I have -3 times -3 plus 4 plus 7. So -3 is already there. I replaced x with a -3, and that's going to be -3 plus 4 squared. So that's going to be 1 squared plus 7. So it's going to be -3 times 1 plus 7. -3 plus 7 would be then this 4. So -3, 4 would be another point. So -3, 4 would be located here. And remember, this graph is going to be opening down, and I should just mirror this point across the axis of symmetry. So there's also this point -5, 4. And that should be enough information now to sketch the graph of the parabola. So it kind of does that. So by knowing the vertex axis of symmetry, and since the coefficient out in front, this -3 tells me that this graph opens down. And by just plotting one more point, I can now have enough information to sketch the graph of the parabola. So in graphing a quadratic function, we may be asked to do several things here. So we may be asked to find the vertex, the axis of symmetry. So remember, the vertex is going to be, the x value is going to be found by using x equals -b over 2a, but we still got to substitute to find y. And remember, the vertex is an ordered pair, x value, y value. And remember, if the graph opens up, it can be a minimum. If the graph opens down, it could be considered a maximum point. The axis of symmetry is simply going to be x equals negative b over 2a. So remember, it's really just the x value of the vertex. From there, we have to determine if the graph opens up or down. So remember, if we have the equation y equals ax squared plus bx plus c, if a is positive, it opens up. So if a is greater than 0, it opens up. If a is less than 0, the graph is going to open down. So if a is negative, it opens down. If we have the form y equals a times x minus h squared plus k, notice how again it's the same thing. So remember, we use this x equals negative b over 2a if we are given the equation y equals ax squared plus bx plus c. We use that. If it's in that form, we have to find the vertex that way. To find the y-intercept, remember, we set x equal to 0 and solve for y. So that's not so hard. The x-intercepts, we have to set y equal to 0 and solve for x. But this may be a quadratic equation. So a quadratic equation, we either can use factoring or the quadratic formula. So remember, the quadratic formula is that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's the formula. So we have to use one of those things. That's where it gets a little complicated, is finding these x-intercepts sometimes. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there are some other little tricks here. The domain, for the most part, for these functions will basically be negative infinity to infinity because there's not any domain restrictions in a quadratic function. But the range, remember, it's the lower bound to infinity. I can use the symbol. So it's going to be the lower bound to infinity if the graph opens up. Because remember, that would be a minimum. The range would be upper bound. Actually, I should backtrack on that. It's the if the graph opens down, it's going to be negative infinity to the upper bound. If the graph opens down. Because remember, when we use interval notation, the lower bound's got to go first, the upper bound's got to go second. So determine if the function is increasing or decreasing. Remember, we have to look from left to right. So your vision should be going from left to right. If the graph is rising, then it's increasing. If the graph is going downward, then we would describe that as a decreasing interval. And remember, when you're doing intervals, you're talking about your x values here. Left to right, we're talking about x values. So like I said, if the function is decreasing, we use this downward for decreasing. And again, we're still focusing on the x values. And determine where f of x is greater than 0. Remember, that's like y is greater than 0. Determine where f of x is less than 0. That is where y is less than 0. So again, that kind of gets into these intervals here of increasing and decreasing. So let's practice some of these strategies. Find the following information given the quadratic functions. So if I give you x squared plus 2x minus 8, to find the vertex, we're going to have to use x equals negative b over 2a. So notice that a is equal to 1, b is equal to 2, and c is equal to negative 8. So I got to take the opposite of 2, which would be a negative 2, over 2 times a, so that's 2 times 1. So that's going to be negative 2 over 2, which is going to equal negative 1. So to find the vertex, so I still have to find the x value. So remember, y is going to equal x squared plus 2x minus 8. And now I have to replace x with the negative 1 now. Negative 1 squared plus 2 times negative 1 minus 8. So that's going to be 1 minus 2 minus 8. That's going to be a negative 1 and a negative 8. That's going to be a negative 9. So the vertex is going to be negative 1, negative 9 for this function. So negative 1, negative 9. The axis of symmetry, remember, it's just x equals the x value, so x equals negative 1. Does this graph open up or down? Well, since the coefficient of x squared is a 1, this graph is going to open up. So it's going to be concave up. To find the y-intercept, we have to set x equal to 0. So again, we have this y equals this x squared plus 2x minus 8. So again, to find the y-intercept, you have to set x equal to 0. So y equals 0 squared plus 2 times 0 minus 8. So y equals negative 8. So remember, if it's in this form, the y-intercept is usually just going to be the constant because everything else is going to turn into 0 there on that. So the y-intercept would be, if I write it as a value there, it's going to be this negative 8 is where it crosses the y-axis. If I want to find the x-intercepts, I have to set y equal to 0. So what happens here is this becomes then, if I'm finding the x-intercepts, you have x squared plus 2x minus 8 is equal to 0. If it's factorable, we want to try to factor it. Well, there's not a GCF, but if I use big T, what I'm looking for are the factors of a negative 8 that give me this 2. And what I'm looking at is a 4 and a negative 2 would do that. So that means that this is going to factor into x plus 4 times x minus 2 is equal to 0. Since it was factorable, we just set each factor equal to 0. X plus 4 is equal to 0 and x minus 2 equal to 0. So x equals negative 4, x equals 2. So it does have two intercepts, two x-intercepts. So negative 4 and 2 would be that. The domain is going to be from negative infinity to infinity. There aren't any domain restrictions. The range, to determine the range, what we pick up on is the graph opens up. Since the graph opens up, the range is going to be the lower bound to infinity. And remember, we're talking about y value here. The y value of the lower bound is the y value of the vertex. And since the vertex was -1, -9, So the vertex was this -1, -9. That -9 was the smallest y value. So my smallest y value is going to be this -9, and it's going to go all the way up to infinity. So the range is going to be this -9 to infinity. So where's the graph increasing and decreasing? Well, we would actually have to graph this thing here. So to get a better understanding of that. So let's see here. So again, the graph, we have this point, -1, -9. So if I just make a rough sketch of this, at -1, -9, so -1, -9, and this graph is opening up. So as a rough sketch, this graph is kind of doing this. So where the graph is increasing and decreasing, so if I start from left to right, as the graph starts to the right, notice how the graph is going down. So it's actually decreasing from -infinity down to where x is -1. So -infinity to, I'm sorry, that's decreasing. Actually, got that where it should be actually I here. So that's going to be -infinity to -1, including -1. And then at -1, the graph turns around and starts going up and starts to increase. So from -1 to infinity, the graph is increasing. Where's the graph? Where is y greater than 0? This is where those x-intercepts come in. So where the graph is greater than 0, if I make a sketch again of where the x-intercepts are, the x-intercepts are at -4 and 2. So from that perspective, you know, I'm getting much more of the graph here. So -4 was one of the x-intercepts, 2 was the other intercept. I actually graphed this wrong. -1, -9 is not there, is it? I did it backwards again. So let me just bring that all over here. So the vertex is actually -1, -9. One, two, three, four, 5, 6, 7, 8, 9. So that's actually -1, -9. So the axis of symmetry would actually be going through -1. And by plotting those x-intercepts, I can see the graph fairly good here. So notice how the graph is going to pass through this -4, turn around and go back up and pass through this too. So again, as we said, the decreasing interval would be from -infinity to -1 would be decreasing. And then from -1 to infinity, it would be increasing. So those are done. Where y is greater than 0 means where the graph is above the x-axis. So where the graph is above the x-axis, what I'm seeing is here, the graph is above the x-axis. And here, the graph is above the x-axis. So that means as far as the x values go, I'm seeing from -infinity to where -4 is, and I can't include -4, the graph is above the x-axis. In union with, it's also above the x-axis to the right of 2. So from 2 to infinity, the graph is above the x-axis. Where the graph is less than 0, where y is less than 0, that's where the graph is below the x-axis. It's below the x-axis here. So that means between -4 and -2, the graph is below the x-axis. So now how the y's are negative between -4 and -2. So where the graph is less than 0 would be between -4 and -2. And again, you cannot include those because at -4, -2, we are actually equal to 0. So we have to use open bounds there to exclude those. So that's where f of x is less than 0, is that interval. So a lot of information to be had in this. So if I want to determine the equation of a graph of a function, if I give you this equation here, or this graph, again, to write an equation of a graph, we're going to use y equals a times x minus h squared plus k, because the h and k would be the vertex in this problem. So y is going to equal a times, and it's going to be x minus 2 squared plus 1. Because remember, the x has always got to be backwards. And since the vertex is at this 2, 1, we now have this. So to write the equation, now all we have to do is find this a. To find a, that's where this other point comes into play. Notice how this is an x value and a y value. So the 5 goes in for y. We don't know what a is, but I can replace x with 0. So we have 0 minus 2 squared plus 1. So this allows me to then solve for the coefficient a. So I have 5 equals a, and 0 minus 2 would be -2 squared plus 1. So 5 would equal, this is going to turn into 4a plus 1. So to solve for a, we have to lose 1 on each side. So 4 equals 4a. So a would equal then 1. So my equation becomes then y equals 1 times x minus 2 squared plus 1. But remember, if a is 1, we do not write it. So we drop the 1 and just say, hey, y equals x minus 2 squared plus 1. That would be the equation for the quadratic function in vertex form. So this question here says, determine if the function has a maximum or minimum, and then determine that value. Well, since the graph opens down, this would have to be a maximum value. Now, to find it, what it is, it's actually the vertex. So to find the vertex, we can use x equals -b over 2a. So remember, when you look at an equation, it's f of x equals ax squared plus bx plus c. So the a is the coefficient of the x squared. So in our problem, we have a is going to be this -2. This b is going to be the coefficient of x, which is going to be 12. And the c would have been 0. So we just got to take the opposite of 12. The opposite of 12 is going to be -12. And then 2 times -2. 2 times -2. So that's going to be -12 over -4, which turns into a 3. So that's going to be the vertex, the x value of the vertex. So to find the y value, we have to substitute in for x. So we have y equals this -2x squared plus this 12x. So I replace the x value with the 3. That becomes -2 times 3 squared plus 12 times 3. And I'm going to use the calculator for that. So I have -2 in parentheses 3 squared plus 12 times 3. And we're getting this 18 for this. So the vertex is going to be 318. But remember, the max is typically the y value. So that means the maximum value should be this 18. So when x equals 3, the maximum value would be 18, since the graph opens down. So that's going to conclude my lesson on working in section 4. This is 4.3. Yeah. So that gives you a little bit of information to kind of go by. So that will do it. 4.3. Look at all that stuff we did. It was quite busy. Have a good day.